A turbine is a machine that converts the energy of the water flowing into rotating mechanical energy for the rotating shaft. The turbine is mainly used as a prime mover for hydroelectric power generation. There are 4 main types of flow components in a turbine. This is the water inlet. There are 2 commonly used metal scroll shells and concrete scroll shells. There are 2 commonly used types of water guide parts, cylindrical and conical. This is a cylindrical water guide. The working parts are various types of wheels. This is an axial runner. Drain part, commonly used elbow type. Elbow type. And straight cones. When the turbine is working, the water flow is introduced by the drinking water part, usually the vortex shell, adjusted by the water guide mechanism to enter the runner and push the runner to rotate. Finally, it becomes the mechanical energy of the spindle rotation. This is the working process of the water turbine. The water flowing out of the runner flows through the tailpipe and is discharged. The working part of a turbine is the runner. It's the heart of the turbine. The form of the turbine is determined by the form of the runner. The runner is a key component that directly converts the energy of water flowing into the mechanical energy of the main axis rotation. The structure and shape of the runner determines the performance of the turbine, and the form and size of the runner determines the form and size of the other components. It can be seen that the runner is the most important component of the turbine. The nominal diameter represents the main geometry of the runner. In China, it is represented by the letter D1. As to mixed flow runner, D1 refers to the maximum diameter of the water inlet of the runner. As to axial runner, D1 refers to the inner diameter of the runner at the intersection with the axis of the runner blade. As to inclined flow runner, D1 means the inner diameter of the runner at the intersection with the axis of the runner blade. As 2 bucket wheels, D1 means the diameter of the edge tangent to the center line of the jet. Generally, according to the characteristics of water flow energy conversion, runners can be divided into counterattack turbine runners and impact turbine runners. Counterattack turbine runner. When the counterattack turbine runner works, it converts most of the energy of the water flowing into pressure energy. A pressure differential is created before and after the runner blades to rotate the runner, converts the energy of the water flowing into mechanical energy for the rotation of the runner. This kind of turbine runner that works mainly by water flow pressure is called a counterattack turbine runner. According to the direction in which the water flows through the runner blades, the runners of the counterattack turbines can be divided into mixed flow runners. Axial runner. Diagonal runner. And 4 forms of tubular runners. Francis turbine runner. Francis turbine runner is also known as floating axial turbine runner. This turbine runner floats in when water begins to flow into the runner blades, change direction on the runner blade, and flows out in an axial way at last. Therefore, it is called mixed flow or floating axial flow turbine runner. The runner of Francis turbine has different shapes due to different application heads. When the runner inlet diameter D1 is larger than the outlet diameter D2, generally used for high head. When the runner inlet diameter D1 is approximately equal to the outlet diameter D2, usually applied to medium head. When the runner inlet diameter D1 is less than the outlet diameter D2, apply to medium and low head. Although the runner of a Francis turbine has a different shape, but the components are essentially the same. Generally, it is composed of an upper crown, blades, a lower ring, a water discharge cone, a leak stop device, and a pressure relief device. The function of the upper crown is to support the blades and form a flow channel with the lower ring. It's shaped like a cone. The upper coronal line is mostly a curve. The blades are the heart of the runner. They play a decisive role in how much energy is converted. The number of blades is usually 14 to 18. The upper end of the blade is connected to the upper crown. The lower end is connected with the lower ring as a whole. The blades are twisted. Its cross-sectional shape is abnormal. The lower ring is located at the lower end of the runner blade. Connect the lower ends of the blades together through it. The shape of the drain cone is a cone shape, bolted under the upper crown flange. Leak stop device is also called leak stop ring. What it does is it creates resistance, reduce the leakage loss of the turbine. According to the shape of the gap formed by the leak stop device, there are 3 different forms. This is a labyrinth leak stop ring, slit type comb type leak stop ring, step leak stop ring. The function of the pressure relief device is to reduce the axial water thrust acting on the runner. There are 2 forms of decompression devices commonly used in Francis turbines. This is a pressure relief plate and a drain hole type pressure relief device. This is a pressure equalizing tube and a drain hole type. Axial flow turbine runner. The name of the axial flow turbine runner is also determined according to the direction in which the water flows through the runner blades. When the water enters the runner blade, it is axial, and when it flows out of the blade, it is also axial. So it is called the axial flow turbine runner. Axial flow turbine runner has 2 structural forms according to its structural characteristics. The one the blades fixed on the runner body is an axial flow fixed propeller runner. The structure of axial flow fixed propeller runner is simple. There is no relative movement between the runner body and the blades. The runner body is a cylinder body. Blades are directly cast or welded to the runner. It is also used to bolt the blade to the runner body. The one that the blades can rotate about its own axis is called axial flow propeller runner. The structure of axial flow propeller runner is more complicated. There is relative movement between the blade and the runner body. The runner is composed of a runner body blade, a blade seal of a blade operating mechanism, and a water discharge cone. The runner body is mainly used to install blades and arrange operating mechanisms. The blade is the main component for converting energy and is composed of 2 parts, the body and the pivot shaft. The blade is mounted on the runner body. On the one hand, it rotates together with the runner body. On the other hand, it can rotate around itself. The angle at which the blade rotates, called blade angle or device angle. The blade angle varies from -20 degrees to +35 degrees. The blade's operating mechanism is installed in the runner body and is operated by means of an oil-operated runner relay. It is used to change the rotation angle of the blade to adapt to the opening of the guide blade. This guarantees the efficiency of the turbine. The blade operating mechanism is divided into 2 forms. This is an operating mechanism with an operating rack. It consists of a blade, a pivot shaft, a shaft sleeve, a rotating arm, a connecting rod, an operating frame, and an operating shaft piston. This is the operating mechanism without the operating rack. Inclined flow turbine runner. The so-called inclined flow turbine runner. That is, its runner is diagonal. The inclined flow runner is composed of a runner body and a blade. Variation of runner of inclined flow turbine with load. The runner blade also works diagonally with the guide blade. Therefore, its structure is similar to the axial flow propeller runner. When the runner of the inclined flow turbine is working, direction of water flowing into and out of the blades. Both are tilted at an angle on the shaft of the turbine runner. Therefore, it is called an inclined flow turbine runner. The runners of inclined flow turbines are generally rotary propellers. It is higher than the application head of the axial flow runner. Runner of tubular turbine. Tubular turbine runner is similar to an axial flow turbine runner. The difference is that it is generally used. Horizontal axis arrangement. Tubular turbine. According to the different connection methods of the turbine and the generator, There are two forms. This is a semi-tubular turbine. This the full tubular turbine. Water flow in and out during operation. The direction of the turbine is the same as the axial direction, straight through the entire turbine channel. Therefore, it is called a tubular turbine. It is suitable for lower waterheads. Impact turbine runner. Impact turbine runner. It is to introduce water flow with a positioning energy into the nozzle. When the water flows out of the nozzle, convert all potential energy into kinetic energy. High-speed water flow with kinetic energy impinges on runner blades to spin the wheel. Converts the kinetic energy of water into mechanical energy for the rotation of the runner. This turbine works entirely with kinetic energy. The runner is called the impact turbine runner.